So this one right here is a pretty challenging problem because we have two absolute value functions here in f of x, and we want to rewrite f of x as a piecewise defined function. So let's start with the basic definition of plain absolute value of x as a piecewise function. So it equals itself, x, if x is greater than or equal to 0, and it equals the negative of x if x is less than 0. So the other function here is absolute value of x minus 1. So if we replace each of these x's, 1, 2, 3, 4, 5 x's, by what's inside this absolute value bar, which is x minus 1, we can rewrite this function also as a piecewise defined function. So over here, I'm going to do that. So the absolute value of x minus 1 as a piecewise function equals itself. Okay, so I'm replacing what's in the absolute value bars, right, with this, with x minus 1. So it equals x minus 1 if itself is greater than or equal to 0. So if x minus 1 is greater than or equal to 0. And it equals the negative of what's inside the absolute value bars. So the negative of x minus 1 if x minus 1 is less than 0. And this is a rather complicated way of looking at it, so let's go ahead and simplify this. Alright, so it equals x minus 1 if it's more typical to solve such an inequality for x. So let's say if x is greater than or equal to 1, and it equals, if we simplify this a little bit, negative x plus 1 if x is less than 1. Okay, so now we are ready to combine these two definitions of the absolute values, absolute value of x and absolute value of x minus 1, so that we can write the entire function f of x as a piecewise defined function. Okay, so let's take a look at the x-axis here. We have one definition for, let's see right here, for x less than 0. Then if x is between 0 and 1, it's going to be different because absolute value of x is defined by x if x is greater than or equal to 0. But it is defined by negative x, or absolute value of x minus 1 is defined by negative x plus 1 if x is less than 1. So for x values between 0 and 1, f is different. And then for x values greater than 1, both absolute value of x and absolute value of x minus 1 are defined the same way. So putting it all together, okay, we will have, actually we don't need to rewrite it here. We'll have, let's see, if x is less than 0, let's start with that. So if x is less than 0, then absolute value of x is defined by negative x. Actually, no, we will want to write it down here. Okay, so f of x is defined by 3 times the absolute value of x, so it's 3 times the absolute value of x, if x is less than 0, is negative x. So 3 times negative x minus the absolute value of x minus 1. If x is less than 0, then we're in this category, x less than 1, so it's defined by negative x plus 1 right there. So what I'm doing is I'm replacing this absolute value and this absolute value by what they are defined as without absolute value bars, depending on the domain or the part of the x-axis that we're looking at. So it's defined by that if x is less than 0. Okay, next, if x is between 0 and 1, our next case, then it's defined differently. So let's see, if we're between 0 and 1, then absolute value of x is defined by plain x. So the first term is 3x. But absolute value of x minus 1 is defined by this, if x is less than 1. So it's defined by negative x plus 1. So minus negative x plus 1 if x is between 0 and 1. And then if x is greater than or equal to 1, let's see, absolute value of x is defined by x, so the first term is 3x. And then it's minus the absolute value of x minus 1. Let's see, if x is greater than or equal to 1, it's defined by x minus 1. Okay, and now we can go from here to there. All we need to do is simplify each of these expressions. So let's just do a little bit of scratch work, I think, to do that. So simplifying here, we're going to have negative 3x for the top. Then distributing this negative, we'll have plus x minus 1. So that's, let's see, negative 2x minus 1 there. Then the middle term is going to be 3x. This will become plus x is 4x. And then minus 1 distributing there. And the last one, 3x minus x is 2x. And then negative of negative 1 is positive 1. All right, that was a tough one.